All right, this is the alternating series test. This is the last test for convergence we're going to talk about. I'm including this one for a few reasons. One is that it's really easy to use. It's actually pretty useful. And also, I really like the logic as to why it works. Okay, so an alternating series test only works when we're talking about an alternating series. And that's a situation where the terms in the series are going to alternate between positive and negative. So for example, this series looks a lot like the series of 1 over n, which gives us 1 plus a half plus a third plus a fourth, etc. Instead, which diverges, by the way. Instead, we've got this alternating series where every other term ends up being even or odd. So because we have this -1 to the n minus 1, which certainly looks confusing, but if you think about what happens when you plug in different integers, when you plug in 1, this thing is even, therefore this whole thing is going to be positive. If you plug in 2, then the exponent is 1, this is negative, and this is going to flip back and forth between being positive and negative. Okay, so the alternating series test says that if you have any alternating series that is decreasing, so this is a fancy way of saying decreasing, and that it limits towards 0, which is a prerequisite for convergence of the series anyway, that this automatically converges. So regardless of the fact that sort of the underlying series, this 1 over n, regardless of the fact that the series 1 over n diverges, because this is an alternating series and because it's decreasing, it's going to end up converging. And I really like the logic behind that because the logic comes from the partial sums. So if we have, let me move this up a little bit. In our example here, if we think about what all the partial sums are doing, so let's just take a number line, and let's just say that so we've got our 0 here, and we have, let's say that this is S1. In other words, it is just the first term. So this is a perfectly reasonable example, but this logic works for any of these, any alternating series. So if our first term takes us all the way up to S1, because this is alternating, our second term has to be negative, and it's going to take us back somewhere. And then so S2, remember that these are our partial sums. S1 is the sum of the first and second term. S2 is the sum of the, S1 is just the first term. S2 is the sum of the first two terms. S3 is the sum of the first 3 terms, etc. And because this sequence is decreasing and switching back and forth between positive and negative, each next step has to sort of be contained in this region. Because the fourth term, so I've got the first 3 terms here, the fourth term has to be negative, and it can't be, it has to be less than, in magnitude, it has to be less than this third term. So it has to be going in this direction. It can stop at any point here, but it can't go past here. So maybe it goes this far, and then the next term goes this far. And we can see that these partial sums are limiting towards some region in the middle. So no matter how what these A's are, no matter how long these arrows are, this alternating series is always going to converge.